Assalamu alaikum, my dear students. I hope all of you are fine and doing well. The topic that we are going to discuss today it is the oxidation state. So basically, by definition, the oxidation state it is the loss of electrons in an atom, ion, or atoms in the molecules during a chemical reactions. This is basically known as the oxidation, and the oxidation state it is defined as the charge with a sign with a sign of two types. It may be positive or negative, or the charge with the sign that an atom would carry in a compound. That apparent charge on an atom will be known as its oxidation state. Now, oxidation state of different compounds can be written as, and we have two types of compounds. We have ionic compounds and we have the second type is the covalent compounds. How we can recognize their oxidation state? Simple, the ionic compounds is having the oxidation state that is the charge on their ions. The charge on ions or the number of electrons loose by the atoms of an element. It may be their oxidation state. For example, we have an ionic compound which is sodium chloride and ACl. Here, the sodium is having oxidation state +1 because it loses one electron. On the other hand, the oxidation state of chlorine it is -1 because it gains one electron. So the oxidation state of both one is +1 and the second is -2. On the other hand, when we are talking about the covalent compounds, their oxidation state only can be measured or decided on the basis of the difference in their electronegativities. And the electronegativities or the electronegativity is simple. The ability of an atom to attract the shared electron towards itself. This ability is known as the electronegativity and it or the oxidation state depends upon the relative electronegativities. For example, if we have an ionic compound SnCl4, here the SN13 is having the oxidation state +4 and that of chlorine is having -1 oxidation state. So this is the simple oxidation state of ionic and covalent compounds. Next we have an example. Example we have a compound which is calcium oxide. As here the calcium it belongs to group 2A, so its oxidation state is +2. On the other hand, the oxygen its oxidation state is -2. It belongs to group 6A as it requires two more electrons and the calcium here lose two electrons. So one just lose the electrons and other just gain the electrons and their oxidation state is -2 and +2. So the oxidation state of calcium will be +2 and the oxygen is of -2. So calcium is basically a metal. It lose the electron. On the other hand, oxygen it is a non-metal and it gains the electron and its oxidation state is according to the electrons gained by the oxygen. Next we have oxidation state of ionic and covalent compounds. So here we have another example for this as I have already discussed. The sodium when an element it is in the free state or in uncombined state then its oxidation state will be 0. Here you can see that the sodium, it is an uncombined state, its oxidation state is 0 and the chlorine is also combining with its atoms, not with the other one as it is a diatomic molecule. So its oxidation state is also 0. But on the other hand, when the sodium just lose the electrons and chlorine gains the electron, now here the oxidation state of sodium is +1 and that of chlorine is -1. So the total number of electrons lose or gain the oxidation state of ionic compounds depends upon this point. But on the other hand, when we have a look on on a covalent compound, which is a water molecule, here hydrogen both have +1 oxidation state and oxygen is having -2 oxidation state. Here because the hydrogen is just deficient by 1 electron and the oxygen is deficient by 2 electrons, it can gain the electrons and the hydrogen can lose the electrons. So that's why the relative electronegativity of oxygen is also high or more as compared to the hydrogen. So that's why it requires -2 oxidation state and hydrogen acquires +1 oxidation state. Next we have the oxidation of typical elements. Basically the oxidation state of group 1 elements or the group A elements. For example, from group 1A to group 7A. Their oxidation is same as their group number. The group 1A elements have their oxidation state +1. The group 2 is having oxidation state +2. Then the group 3A is having +3, +4, 5. Up to the 4, they are having oxidation state in plus. And then we have from group 5 to 7. Their oxidation state depends upon two things. It may be equal to their group number or it may be equal to the total vacancies for electrons present. For example, in the group 5A, it is having 5 electrons and there are 3 vacancies. It can add 3 electrons, so its oxidation state is +3. On the other hand, the group 6, it is having 6 electrons and it can add more 2 electrons, so its oxidation state will be -2 because it can gain the electron. It is a non-metal. And the group 7A, they are having already 7 electrons in the valence shell and they can add one more electron. So their oxidation state will be -1 by gaining one electron. So this is the simple oxidation state of typical elements. They have their oxidation state same to their group number. So group number or the number of electrons present in their outermost shell or the valence shell. Then we have the oxidation state of the transition elements. Basically, the oxidation state of transition element it just variate. Why it is going to be variate? Because when we have look on the iron, it may have the oxidation state +2, +3, +4, +5, and +6. So all these oxidation the iron may have. So basically, transition elements are known as the group B elements of the periodic table and their oxidation states equal to their group numbers as it can be seen from the top. Or on the other hand, due to the greater number of electrons available in their valence shell. So they have greater number of electrons available in their valence shell. They may have variable oxidation state. Like here, with zinc, it just have oxidation state +2. The copper can show the two type of oxidation state where +2 and +3. Like nickel, it can have +2, +3, and +4. And manganese, it can show the oxidation state up to +7, starting from +2. It depends upon to which atom it is going to be make the bond. So all this depends upon the number of electrons shared by because they have their d orbitals or they have to fill their d orbitals. For this reason, they can show the variation in their oxidation state. So this is all about today's lecture. I hope you guys understand and if you have any queries, you may ask me about that. And the next topic that we will discuss it is the electrical conductance of the elements. For that time, you guys have a good day and Allah Hafiz.